Hey guys, today on the math channel we'll be finding out if the square root of 2 is irrational. We'll prove this by finding out why the square root of 2 is not rational. But what is rational? Well, what is not rational? Well, rational numbers can be defined as rational numbers are numbers which can be presented as a fraction. For example, 2 is rational because it can be presented as 2 over 1 or 1/2, 1 over 2. So I'm going to do this by doing the square root of 2 is equal to a over b, which we know it's not. We're just proving that it's not. Okay, so for this to work, we need a and b to be both integers. An integer are numbers which are both positive and negative, and they're whole. So I'm going to start by saying the square root of 2 is equal to a over b, where a and b can't simplify, so they don't have any common factors, and a and b are integers. I do a little rearranging and I end up with 2 is equal to a squared over b squared. I times by b squared, but yeah. Then I divide by 2, and now this is the interesting part, because I find out that a is even by, so if a is even, for example 6 squared, it would be 36, and divided by 2, it would be 18. So 18 is an even number. That means a must be an even number. But if a was odd, for example 9 squared is 81, divided by 2, that doesn't work with b, see, because b can't be 4.5 because it's squared, and b is an integer. So that means a must be even, and if a is even, then b is even, because if this side is even, that means this side must be even. So an even number like b squared, we know it's an even, and if we square root it, we would get an even number. So we know a is even and b is even. But then we have a contradiction. If a and b are even, then they can simplify because they have a common factor of 2. But here I specifically mentioned that a and b can't simplify. So we have a contradiction, and thus I have proved that the square root of 2 is not rational. Thank you for watching.